All right, welcome to part 2 of section 2.3. We're going to go through the units, and these are similar to section 2.3 part A, numbers 2 and 3, 6 and 7, 10 and 11, and part B, numbers 2 and 3, 6 and 7. Now I only did one example from each of these because it ends up being kind of repetitive, and you'll kind of catch on to that. The first thing we want to do is I've given us feet for the units for our first example using a rectangle. Now I would like to go back and look at the formula. To find this, you'll go to the iLearn, then hit the folder course, and then go to resources, and it's the second to the last one in there. So in here I'm going to come to rectangle and notice that I have length and width. I have 2, which is unitless, it's just a number, 2 times length. Now length, it has a unit of length. And again, 2 is unitless, and I have width, which is being measured in this case, feet. So I have feet being added to feet. Because I'm just adding, the perimeter is just feet. The area, however, ends up being length times width. Using our knowledge of units, that means I have feet being multiplied to feet, and I'm just worrying about the units. I'm not looking at numbers. If I have feet times feet, this means that I end up with feet squared. And I can type it feet being raised to the 2, or I can type it square feet. Either way is appropriate. Let's move to the next one on the circle. First with circumference and then area. Coming into here, we're going to find the formula for circle. Circumference. 2 is just a number, so there's no unit attached. Pi, while it does have its own letter established, pi is just a ratio of a circle's circumference to its diameter. So pi itself is unitless. It's just a ratio, a division of numbers, such as 1/2. 1/2 is 1 being divided by 2. So pi has no units attached. So I have no units here, I just have radius. And radius has a length. So my circumference is whatever the units are, whatever the radius is. And in this case I was given centimeters, so it's just centimeters. Now area, I have pi r squared. We talked about pi having no units attached, but radius does. A radius is a length or a unit of length. And in this case, I have radius times radius. So this would be centimeters times centimeters, because I have whatever the radius is, the length of the radius, being multiplied to the length of the radius. So my units are being multiplied as well, which gives me centimeters squared. You'll kind of notice here as we talk about area, it's a squared unit. So if I'm moving to lateral surface area and surface area, again, you'll kind of find the pattern that it's being squared. But just to look through it again, the lateral surface area, over here I have the formula. So pi is unitless. The radius has a unit and it was given to us in inches. The length, or the slant height here, is also given a length, which is in inches. So to find the units for the lateral surface area, I have inches being multiplied to inches here because I have the radius being multiplied to the length, and their units are attached. So inches being multiplied to inches, which shows me that I have inches squared. And we already talked about how all of the areas that we'll see from now on, the unit is in whatever the unit is squared. Let's see if that applies to the surface area here as well. Pi is unitless, radius times this slant height. So the radius is measured in inches. So I'm going to come over here and type that in. I have inches with the radius, and this slant height, L, is also in inches. Then I'm going to be adding it to pi is again unitless, but here I have r squared. That means I have the radius times itself, which is being measured in inches, so it's inches times inches. That's beautiful because if I have inches times inches, which is inches squared, then I can go ahead and add it to inches squared and get my final answer, which I did. So in this case, the whole thing is also inches squared. Or you can think of it as being an area, and therefore it is is squared. Volume, this one I have 1/3, that's unitless, pi also unitless, but the radius is being squared. So I have inches being times to inches, which is inches squared. And you'll notice it kind of matches here as well, being raised to the 2. Here I have being raised to the 2. Oh, I don't need an equal sign. I'm not creating an equation or anything. So I have my inches squared, but I'm also multiplying that by the height, which is also measured in inches. So how many inches do I have there? 3. The inches squared and the inches over there, so I have inches cubed. Or I can type this as cubic inches. And you'll notice on all of these volumes, you'll have something, your unit being cubed, or you can type it out cubic, whatever the unit is. And that's for volume. But just double checking once again, this is section 2.3, part B, numbers 2 and 3, similar to anyway. So this one I'm working in yards. Again, surface area, we already know is going to be squared, but just to double check, we're going to come over here and look at the formula. I can discount 2 and pi because they have no units attached, but r does, r and h, and those are being multiplied together. So this is going to be r is being measured in yards, or yard, and I'm going to times that by h, which is also being measured in a yard. Then I'm going to press add so that I can see the units on this side. 2 and pi again are unitless, I can ignore those, but here I have r squared, and because r is being measured with yard, the yards are also squared. Over here, yard times yard is yard squared. I can add yard squared and yard squared, which is good for my formula over here in finding my answer. So when I add yard squared and yard squared, I still end up with yard squared, or square yards. Oops. Square yards, or square yard. Which we already talked about as area having a square, because I'm only working in 2 dimensions. Volume, I'm working in 3 dimensions. I have length, width, and height. In this case, my length and my width are the r. So pi, again, we disregard as being unitless. R being squared means I have yards being times to yards. So r being the radius times the radius, yards times yards is yards squared for this portion. Now I need to times that by the height, which is also being measured in yards. How many yards do I have? Yards cubed, or cubic yards. And you kind of notice where we come up with the idea of 3 dimensions and 2 dimensions. 2 dimensions is flat, so I have length and width, so it just goes up and down or left and right. And the volume, I go up and down, left and right, and front to back. So that's where the 3 dimension comes in. And the last one, this is similar to section 2.3, part B, numbers 6 and 7. So this is when I'm working with a sphere. The surface area of a sphere is kind of like a balloon, so you're just looking at the outside, or a way of painting something, the surface area. The volume is like if it were a balloon, the water going inside the balloon for a water balloon. So we'll come over here. 4 and pi are unitless. but r is being squared, and r is being measured in millimeters. So I have millimeters being times by millimeters, which is millimeters squared, and it even kind of gives you a hint right there with the r being squared. The volume, 4/3 is unitless, and so is pi. R raised to the 3 means I have r times r times r, so 3 of them, which means I'm multiplying the millimeters times millimeters times millimeters, which gives me millimeters cubed. And I can write those out of like we did before as square millimeters and cubic millimeters. There we go. That is part B, or the second part of our section 2.3, discussing the units. Good luck on your homework, and good luck on the test.